So the first question that I've carefully prepared, and that I have right now in Evernote. Right now, it seems the big limiting factor in storage and network storage is bandwidth. And so I guess the sort of larger question I would ask is, how do you think bandwidth is going to evolve in the next 3 to 5 years? How will that affect, how's that going to affect storage and the storage markets in general? And we'll start.
I'll let Evan start.
What do you mean by bandwidth? Are we talking about the SAS backplane bandwidth, or are we talking about network bandwidth? Because those are two really different types. So I don't know who's finding network bandwidth a limitation. Anybody? Really? Because I'm getting 10 gigabit ports for like $250 all in for the switch port and the NIC. So I can push 2 by 10 gigs. I have an extended store box with 48 spindles, like fully pegged. You guys can't do that? Nobody else can do that? I mean, I don't see network bandwidth as a problem. I mean, am I just the only one? I mean, network bandwidth is cheap. It's almost the cheapest it's ever been. 40 gigs is coming along. I mean, I don't know what's the problem. Seriously.
Have anyone say it, or you want me to?
I mean, spindles are slower.
Yeah, I mean, the great bottleneck, IT is sort of a game of pass the bottleneck, right? And these days, I mean, there's physics. There's only so fast you can get a disk drive going. And so typically it's the I/O bottleneck, right?
Yeah, I'd say IOPS is a much bigger bottleneck.
These days. And so hence, the evolution of SSD cache, et cetera. So there are a lot of things going on in that space. And then our product and others that leverage SSDs to get you around the disk head bottleneck, et cetera. So having said that, I would argue, I mean, where does the bottleneck for bandwidth come in? It does take a long time to move data around, right? So we kind of take it for granted, but at the bottom of the stack is an immovable object, which is your data, right? And getting it out, moving it around is really, really hard. So I think Randy would probably agree that you're going to see more compute come to the storage, and part of that is that.
Well, the wide area network's a different issue than in the data center, right? I mean, the problem is that the wide area network is fundamentally constrained by the number of fibers that are in the ground.
Can you repeat that for the camera?
The wide area network's fundamentally constrained by the number of fibers that are in the ground, right? I mean, it's fundamentally constrained. So the prices on, even when you're doing a metro Ethernet, 10 gig, I mean, it's just significantly more expensive than cross-connecting between a couple of racks in the data center. But the reality is that you can go to Quanta and you can buy, a 48 port 10 gig E switch, that's full line rate non-blocking for $6,000. So I mean, in the data center, we're going to 10 and 40 and 100 gig very, very quickly, much quicker than we did the 100 meg to 1 gig transition, and much, much quicker than we did the 1 gig to 10 gig transition, which was painfully long. I mean, a lot of that's being driven by cloud computing and virtualization of higher densities. And it's getting cheap really, really fast, much faster than I expect. I mean, nobody I know is deploying on 1 gig anymore. And a lot of people are looking at 40 gig. And, people like Facebook are pushing for 1 terabit. So I just don't see, in the data center, I don't see a network bottleneck.
Okay. No, but to your point, then you get the issue of the cloud on-ramp and so forth, right? Yeah, so that's more of a telco issue. But even in the data center, I mean, moving the data, the massive data you were talking about, so to be a little more explicit, it really sucks to turn off your legacy SAN and move that data, right? And so how do you address that? Better networks. Also, stop growing the legacy SAN would be our argument. I mean, go to something where if you decide you don't like your storage vendor, you move the disks, physically move the disks. So, try taking EMC populated disks and managing them with NetApp. It's not going to happen. So fundamentally, the ability to make your data a little more fluid, I mean, beyond a marketing term, but actually being able to move that data around it's getting better. But still, you're talking, I mean, the disk drives are going up too, right? I mean, we have an article in our internal social network about trying to speculate when you're going to have 60 terabyte drives. I mean, they're coming. And even with a bigger bandwidth, you're still going to have challenges moving that data around. Sorry.
Well, I was just going to address the, you know, when you talk about disk drives being the bottleneck, I mean, we certainly agree that SSDs are emerging. We believe that it's a complementary business, and it does improve the overall performance of the system. We also think that by tiering the storage, right, as Randy alluded to in your presentation today, still makes sense. There's a misnomer out within the public that, you know, disk drives are going to be big, fat, slow drives, and that just simply isn't the case based on the applications that are being introduced into the market. There's still a need for SSDs, and for today, 15K, 10K drives, and we're thinking about things, how do we innovate on top of that? How do you leverage things like hybrid and et cetera to increase overall performance within the system? So from a fundamental building block, we believe that disk drives, you know, we need to continue to innovate, and we're out talking with as many cloud service providers, system builders, software partners to understand how we can continue to innovate on disk drives to make them higher reliability, better performance, and et cetera. So we aren't standing still. You know, we're all trying to figure this out as an industry. And then to address the overall capacity, you start thinking about, you know, the capacity of disk drives, and, you know, a lot of time people think about drives in units, and I know that the recent floods in Thailand, I'll save your question, recent floods in Thailand, you know, opened a lot of people's eyes to you know, a unit standpoint, but also capacity. And there's this insatiable need for more capacity as we get more tablets and as we get more smartphones and ultrabooks into the market itself. You know, it's creating more and more data at the cloud, at the data center, and we are trying to keep up with the exabyte demand, right? So I think 5 years ago we shipped 100 exabytes. I think last year it was roughly 400 exabytes. We expect by 2015, 2016 we're going to ship a zettabyte. If you start thinking about a zettabyte, that's all the data that's been digitized from 1957 to 2010 or something like that. So you start talking about massive amounts of storage that's needed. I think the projections by 2020 is somewhere between 7 and 35 zettabytes. And you start thinking about that as an industry, you start asking the questions about, you know, can SSD replace disk drives? And I would say it's really tough. It's really tough to replace all that rotating media and storage out there. But, you know, what we have to do is innovate and figure out how we can provide better performance to the industry and use SSDs to complement the industry to make sure that we're not the bottleneck, right? So how do we do it smarter? And we need your help, you know, whether you're a builder, a reseller, or a cloud service provider, because we can design better products.
So you effectively answered my next two questions. So one, I actually wasn't going to ask about it, but thank you for bringing up Thailand. And my next one then was about the death of the disk, which you would disagree with. The disks aren't going away anytime soon. They're not going to be supplanted by SSDs or any other technology anytime soon, you see. Here, we'll hand that up to you.
You want me to start?
Absolutely.
I'll finish. So no, we don't. We don't think that happens. You know, a lot of times people ask, you know, are we threatened by SSDs? First of all, Seagate manufactures SSDs, and we've got a relationship with Samsung after the acquisition of the Samsung deal that puts us in a good position to you know, leverage that relationship. So we see that as a complementary business. But again, when you start thinking about disk drives outside the units and start thinking about the overall capacity, I think that the numbers are out. It would take something like $500 million of investment to go build enough fabs, to go build enough SSDs.
500 million or a
billion? Billion. To go generate enough SSDs, right, to go replace that 7 to 35 exabytes or zettabytes that are out there. It just simply can't be done to go after 25% of the overall market. It's just, for us, we don't think it makes sense. Can it happen? Will it happen over time? Yeah, maybe. But I think this growth of data, there's still going to be room for rotating media behind the scenes.
Sure. I mean, I think that there's a lot of problems with rotating media. It's hard to see a future without them anytime really soon, but I mean, it seems like there's a lot of people trying to solve that problem. I mean, they consume a lot of power. Spinning down is one answer, but that's only a partial answer, especially if you need to get access to what's there. And the reality is that there's a lot of stuff in the laboratories that people are trying to bring to light. SSDs are probably the leading, the thin end of the wedge of a number of different kinds of solid state solutions that we're going to see roll out over, the coming years. And people are doing some very interesting things with solid state technology where the controllers are basically being smart enough to think about the way that they write the data in a different way. And so when you talk about solid state technologies, there's sort of that, endurance problem. And the reality is that it's a different kind of problem for solid state than it is for spinning media. And the problems that people are solving now, kind of the thin end of the wedge, are going to be applicable to a number of the different kinds of solid state technologies out there, and people are going to get better and better about it. Now, is it going to, replace all rotating media soon? I doubt it, but, is the top end of the market going to go away? I don't see a future for 15K RPM disks very, very soon, if it's not already there. I mean, the number of IOPS you get, the price performance, just already sort of favors SSDs, even though they don't have the same level of endurance.
I agree with both guys here. No, yeah, exactly. No, I guess you were talking about zettabytes, and I think we're nowhere near sort of capping out the demand for storing data, and so we all take it for granted probably, but growing 50, 60% a year, how could this be? We're storing all the more data this year than, I don't know, the history of mankind or something. I don't know. It's not quite that extreme, but it's getting pretty close. So you would think we got to be getting somewhere close to we're nowhere near close to that. So if we, let's say, with good compression, sequence the genome of everybody in the world, we'd more than use up the worldwide supply of disk drives. I think it's coming. We will sequence the genome of everybody in the world, and so that's one example. If you were to actually store and do big data analytics or what have you on the data that your average airplane gives off in a given flight, you were to store that, they flush it now because there's not enough data management around. If you were to store that, you'd go through the worldwide supply of disk drives in about a week and a half. So there are a lot of problems. 1 week. Yeah. So there's 30 to 40,000 flights, a day in the U.S. as an example. So I mean, I guess the overall point here is that the demand here for data storage is just going to continue to boom, and as such, I think it's accretive. Personally, I mean, I would tend to agree a little bit on the primary, certainly for random IOPS tier, but on the other hand, I think you're going to see growth in both sectors for my lifetime, certainly.
Okay. So next, and we will take questions from the crowd. Next question on the list. So what are the limits? I mean, other than there's the sort of obvious, and whether it's architectural or physical or whatever, talk about the limits of where we are today. What's the big innovation that's needed for today's storage models? Whether it's evolution of architectures or various, maybe there's some elemental and piece parts technology that needs to be changed. What's the one thing that's sorely lacking, and what are the big opportunities? I'll start with Randy.
I mean, I guess I just kind of go back to the earlier part of the conversation, which, is that data has a certain amount of gravity. I mean, if you look, at least in the U.S. market where I have a lot of familiarity, there have been a number of cloud storage vendors like Nirvanix and OmniDrive, and I don't know, there's like another 5 or 10 who all focus on storage-only solutions, and almost all of them wound up being in archive and backup business models. The exceptions were object storage or other kinds of data storage solutions that were public services that were attached to compute. So Amazon's S3, Rackspace cloud files. I mean, as far as I can tell, the reality is that data has a certain amount of gravity. And, there is this problem of pushing the data over the wire, over the wide area network wire. And so you see, Amazon, for example, accepting FedEx shipments of, disk drives, and then they load it into S3 for you. But what's interesting is that, again, I still, say that the bandwidth problem doesn't exist really in the data center. So what you see there is people really converging compute and storage, like with solutions like Hadoop, where, it's all commodity boxes. And what's interesting about that is that if you run all commodity boxes and all your commodity boxes have 12 cores and 96 gigs of RAM and, 12 2-terabyte drives in them, and then, 18 months later, you can upgrade them all, run the same software, compute, crunch the same problems, but you've got double the disk drive capacity because it's 4-terabyte drives, and you've got double the cores, and you've got double the RAM, then you can sit there and you can ride that curve for a very long time, right? And you can sort of grow your system because it's all open technology simply by continuing to upgrade the plant. While the software stays the same, the data stays the same. So you've got the compute really co-resident with the data, and you're doing all the processing with it right next to it. And I think that's really started to change the game. And I think that's why a lot of the financial services guys are so keen on Hadoop and sort of this open storage stuff. It's because they get a lot more flexibility, and they don't have to refresh by buying a new VMAX or a new whatever. And they don't get locked into a lot of sort of dead-end technology like, who's really going to deploy fiber channel over Ethernet? Seriously.
No, I think that's so that's a little bit of a softball. Obviously the great issue is the storage business models of the legacy vendors. But that's I think there's a lot of truth to that in terms of spend. When you're talking about half of the IT spend of, say, the NSA supposedly going to storage, it's kind of ludicrous because they have a lot of cool gadgets that they spend whatever they want on. And they're spending half of the total to, I was going to say to get good spinning disk, but obviously all the money is going to the legacy vendors, some to Seagate, I'm sure. So, there is a business model fix, I think, that's fundamental to IT, moving forward. But so setting that aside, we ought to call the fix open storage or something like that. But setting that aside, I think, it's people. If for me, it's people, and it comes down to so we're making things simpler and simpler at some level. We're abstracting away, storage. We're extracting server management. We're making things easier, and so therefore, you would think you wouldn't need people that really know how to run a, always up data center, right? It should just work, but it doesn't, right? And so I think actually there's a real danger that we don't have enough quality operators. We don't have enough people that know how to write the applications that Randy was talking about before to actually exploit today's architectures. I think, to the extent that this does not become fully democratized, and it really centralizes in the Googles and the Amazons of the world and so forth, we're going to look back on it and say, the guys with the most computer scientists won. So I think there's a real fight going on there as well. Is this stuff going to be somewhat of a black art to do at internet scale, or are people like cloud scaling going to help other people, plus the internet scale guys, do it massively, or not? I personally, when people ask me what our bottleneck is as a company, it's the people. It's getting the right kind of people who are articulate and can actually credibly talk about how to do this at multi-petabyte scale. That's the big challenge. And maybe we're educating more of them, or maybe, they're all, I don't know, maybe the Facebook IPO screw up will help us all because it'll shake a few of them out of there. I'm not sure about that because Anyway, but yeah, I would look to that. Do we really have the skill sets in place to take IT to the next generation, or is all our data going to end up in one of X number of clouds, who has all the smart guys to keep this stuff up and running?
I don't really have a comment outside of what these two have said, so
Okay.
I think they sum it up.
All right, so then let's turn it around. So the last question was about sort of what are the limitations. So what's the coolest thing in storage that you've seen in the last 12 months? And maybe the answer is nothing. Maybe that's sort of the cynical and jaded among us might say. But if you had something, if there's something you could pick, that's some innovation, some product, some what would you actually say?
Well, what I'd like to talk about is what's coming, but I'm not going to do that. We're going to hold that off. But certainly, for me, being in the disk drive industry now for about 15 years, what's exciting to us at Seagate is not only this thing that we call the cloud, it's clouds, right? For us, we have a more holistic approach, and though there's some marketing gamesmanship being played on what is a cloud, what's not a cloud, by true definition, Seagate views an enterprise cloud as elastic and scalable and charge-backed and et cetera. But we start to look at the world in how does it impact your mobile life, your home, your business, your enterprise, your data center. And we start seeing opportunities to have a massive clouds build out, if you will. So what's exciting for us and what we're starting to see is, how do you create this mobile cloud, right, around your tablet, your laptop, your notebook, your netbook, your smartphone. And is there a way that we can create, a personal cloud and sync that back into your home with a home gateway system where you're managing data and sharing data, and how do we link that back into the cloud and the services around that? And by true definition, is that a cloud? I'm not sure, but things that we're thinking about is, how do you get this quality of service, right, and have access very close and quick to you, on the edge of the network? Those are the things that we're thinking about, and for us, it's pretty cool.
Yeah, coolest stuff. I mean, there's a lot that we're doing, some of which we can talk about, some of which we can't. I think it's okay to say that storage, and I'm not sure if Bill would agree with me on this, but I think it's okay to say that a lot of what we do fundamentally isn't and shouldn't be too cool, right? I mean, a lot of it is where the data lives, hopefully forever. And so, a lot of what we do that I get excited about, as Bill knows, is around how do you have a total system all the way from the point of marketing, being accurate, all the way through potentially decommissioning the box that actually is of high quality. And that stuff is really, there's a lot of moving parts, a lot of parts within IT, within the company that you might be using your product, a lot of parts outside, us, the integrator, the hardware vendors, the solution, the whole thing together, coming together to provide a solution that gives you freedom and better quality than the legacy stuff is a big deal. And I think I don't know if it's cool as much as it's, ruthless blocking and tackling is what I see. But Randy knows about cool more than I do, so.
Now I feel the pressure. I have two things. So if you saw my presentation this morning, I talked about Cassandra and the Netflix use case. I think that's pretty damn cool, like scaling out your database cluster from 50 to 300 nodes and getting linear scale out. I'd never seen anybody make that actually work, so I think that's pretty cool. But that's in the presentation. The other thing I think is really cool is that the React technology, the React guys did this very, very clever hack. So they basically have this data store technology. It looks like Amazon Web Services Simple Storage Service S3, which means you have n number of replicas of these objects, and then you can do the thing they do different is you can do MapReduce on top of it, kind of like Hadoop plus HDFS. And what they did in the last year that was pretty cool is they actually created a client that would basically be a React client that would synchronize a subset of the data set. And so you can run it on on small devices like iPhones and tablets and things like this. And you can synchronize a subset of the data from a bigger React cluster. So you can use that for doing things like build your own CDN. And why that's particularly clever is that means you can also start to think about doing MapReduce across those data sets. So you could start doing MapReduce across people's mobile phones that have portions of data that's being synchronized back to sort of a cloud-based service. So you could think about sort of the SETI at home or protein folding things people have run. You can think of sort of a more generalized framework for being able to do that across all these ARM processors that get very good sort of power performance ratios. And I think that kind of stuff is really, really cool. It's not really well known, but like a lot of the cable operators, they deploy these systems into your homes, these DVRs, and a lot of them have a bunch of free space that's left for the provider, gigs and gigs of space. And when you count it all up, it's, hundreds of petabytes of storage, at the edge of the network. And I don't think anybody's really started to figure out how to do clever things with this. And I see the REAC sort of like edge caching component that has some compute as being we're going to start seeing people doing really, really clever hacks where they're doing edge computation for, video on demand streaming and other things. And it's going to, open up all new use cases. And I think that's the cleverest thing I've seen.
So, and now we've come to the end of my prepared questions. And so we will now begin operating without a net and ask you if you have any questions. And so we'll start with Mr. Tony Tice.
In which sector will be the data growth biggest? Media? Whatever.
Biggest data growth sector?
No idea. That's an Evan question.
Yeah, that's a great question. Actually, we tend to see it today. I'm thinking about some of the larger deals are like, you would call them second or third tier. Backup kind of out in the cloud is just absolutely enormous. The biggest storage users in the world are keeping track of what other people are doing. So I think I don't have any sort of clearances or anything like that, but I do know that much. So it's growing. You're taking 2 cameras on a drone that have okay definition that are stored for some period of time. Let's say the video is stored for a week, and the mandate is to go to 6 and then 12 HD cameras stored for a minimum of a year. So they're definitely pushing the frontiers of what is possible today and the amount of data stored. So, and one reason they're doing it, I knew Randy would have cooler stuff, but one reason they're doing it is because you do have analytics algorithms now that will tell you, that will replace the humans in looking at the video, or at least leverage the humans. So, alarm on the obvious. Somebody just left the building, or more than 3 people left the building, or, et cetera. Or 3 people left the building, or I don't know, maybe the kids left the building, or whatever the use case may be. So that stuff is pretty amazing. And then it can, facial rec, all that stuff. So for better or worse, that area of demand growth is absolutely booming. And I think is, certainly it's the biggest, they're the biggest users in aggregate, I would think.
What about user-generated content? The YouTubes of this world.
Yeah, that's booming even more. Video, I think, well, I don't know if even more, but yeah, it's just absolutely. Even at the KT cloud, as you know, some of what's going on is it's a mobile connected cloud, and they're giving away access to their uCloud, and they call it uCloud users, and so yeah, that stuff's just boomed. I think, and it should go greater. And when you can have a home, map my own genome thing, and probably going to be like, that's going to be a part of your Facebook profile in the future, right? Just upload your genome, and then you can have, no, actually, I have a friend who has a, I'm joking about it, but it's called, it's a good plug, actually. He's a serious, geneticist. He's got his PhD in it, but called My Daughter's DNA, and because he has a daughter with a medical issue, and they are uploading genomes and actually comparing them. And if you think about that, it's pretty astounding. The sort of stuff that you might want to do. You probably wouldn't want people liking your genome or no thumbs down or whatever. But these are folks saying, hey, I got to hack the genome. You know, I mean, obviously, if you're on that long tail and your daughter or what have you has a medical condition, you're going to use the internet just like the rest of us to try to solve problems. So yeah, all flavors of user-generated content are booming. That's a good point.
Like you give 6 billion people a computer and an internet connection, you're in trouble.
But they generate that data, and then somebody keeps at least one copy, right? So,
At least one.
yeah.
Okay, well, we have a time for probably about one more round of question and answers, and Mr. Panov.
Hello. My question is to Mr. Powell. Software approach to storage has been around for a while. And some other companies tried. I wouldn't say they've failed, but probably didn't find the business model. Some others have some success, like DataCore. What's different this time? What's Nexenta's, talking about future of storage, what's Nexenta's advantage to make it happen? And a quick second question, do you see dedupe becoming mainstream feature in primary storage? Dedupe.
I think a big difference for us is just you know, we're on the shoulders of giants, right? And in particular, Nexenta doesn't exist without the 150 million or so that Sun and just the raw and experienced brain power of people like Bill Moore and Jeff Bonwick, who created CFS. And you know, at the end of the day, can you keep the data safe forever? Can you go toe-to-toe on a feature parity with the legacy vendors? And if you can't, then you're in a related market, but you're not actually in the truly enterprise class storage market. And so we are. I mean, we believe we are, and we could claim credit for it, but actually it's, you know, it's largely the file system that we have inherited and we've added to. And speaking of adding to it, to answer the second question, I mean, I think inline dedupe is really powerful. And unlike most of what we do, it doesn't really, most of what we do, we don't tax the hardware that much, right? I mean, we're be bottlenecked somewhere else. Dedupe, you know, you need memory today, the way we do it, and CFS does it. You need memory, you need some processor power. And so the good news is those are getting ridiculously less expensive, you know, thank you Romley and all of that stuff, because we always think of Moore's Law as being, you know, Moore's Law every 18 months and so. For storage, Romley is like more like a tenfold improvement, right? So, I mean, we're right in the midst of Intel saying, I like that market, I'll take it, right? And so that's helping us. They also have special instruction sets that are now up on the chips, and we're going to be leveraging those in dedupe. And in 4.0, keep me honest, right? We will have some more optimizations of for dedupe as well, because as it is, we almost discourage folks from using it for primary. You certainly can. We've got some folks, especially in the, say, hosted VDI space, where you have cost and you want to get performance. That their business is almost built on our inline dedupe, right? They're getting, I don't know, 300-to-1 ratios. It's great. They love it. We have other users who turn it on. Oh, I wonder what this does. Click. And they have 8 gigs of memory, and it's not good, right? So we've had to be, we're extremely cautious in general about dedupe, and our default is for primary is, you know, just be careful what you ask for. We think with 4.0 it'll be more generalizable. People will use it more frequently. I mean, quite frankly, compression's pretty darn cool as well, right? And we've got all sorts of compression flavors, or thin provisioning, pretty cool. You know, you've got some of these things which are storagey features. But they're useful, or even link clones and you know, the things that you do when you're provisioning VMs, so that you don't ever create another space on the disk that's got the, all of which. So I guess the point being that there's many techniques so that you can well utilize the data space, a capacity that you have, but definitely primary dedupe's one that useful some today will be more useful, at least in our case, going forward.